Children, these are physics daily practice questions for day 3. Now you come to the first main question. 4 alternatives are given for each of the following questions. Choose the correct alternative and write the complete answer along with its letter of alphabet. So what is that first question? Commercial unit of energy is. What is the commercial unit of energy? Here the 4 options are A, watt hour, and B, kilowatt hour, C, joule, and D is kilojoule. And what is the answer? The answer is B. What is the answer? Option B is the answer. What is that? Kilowatt hour. Kilowatt hour is the answer. So write the answer B, kilowatt hour. That is, generally it is called unit of energy, that is kilowatt hour. And the second question. What is that second question? A doctor has prescribed a corrective lens of power plus 2D, means plus 2 diopter. The prescribed lens is convex lens with f equals 2 meter, convex lens with f equals 1 by 2 meter, concave lens with f equals 2 meter, concave lens with f equals 1 by 2 meter. So what are the options? Option A is convex lens with f equals 2 meter, and option B, convex lens with f equals 1 by 2 meter. Option C, concave lens f equals 2 meter, and concave lens with f equals 1 by 2 meter. Here the power of the lens is plus, so it must be convex lens. And also you know that power is the reciprocal of the focal length. So here we have to take convex lens with the reciprocal of 2 is 1 by 2. So the option B is the answer. What is that answer? Convex lens with f equals 2, its reciprocal 1 by 2 m. Convex lens with f equals 1 by 2 m is the answer. So take that, the answer option B is the answer, that is convex lens with f equals 1 by 2 m. Next, the third question. The SI unit of resistivity is. What is the SI unit of resistivity? Here 4 options are there. Option A is ohm meter, option B is ampere, option C is ohm, and option D is volt. So then what are the answer? You know that unit of resistivity is ohm meter. You know that ampere is the unit of electric current, ohm is the unit of resistance, volt is the unit of potential difference, and the option A, ohm meter, is the unit of resistivity. So you take the answer. What is the answer here? Answer is ohm meter, option A. Next question, fourth question. What is the fourth question? If the image formed by a convex lens is of the same size as that of the object, what is the position of the image with respect to the lens? So, same size as that of the object. When the object is at 2f, when the object is at the radius of curvature 2f, then the image forms at the 2f of the lens of the other side with the same size as that of the object. So here the position of the image is at 2f2, you can say. Position of the image is at 2f2. That is, when the object is at 2f1, the image forms at 2f2 with the same size as that of the object. So the position of the image, you can say, the position of the image with respect to the lens is at 2f2. So you write that the position of the image with respect to the lens is, at 2f2, that is at the center of curvature. At the center of curvature, that is at 2f2. So when the object is at to F1, the image forms at 2F2 with the same size as that of the object. Then you take the next question. So then what is fifth question? Fifth question is define power of lens. Mention its SI unit. What is that question? Define power of lens. Mention its SI unit. Simply you can define that the power of a lens is defined as the reciprocal of its focal length. The power of a lens is the measure of its ability to converge or diverge a parallel beam of light on refraction through it. A convex lens of shorter focal length bends the light ray more through larger angles by focusing them closer to the optical center as compared to the convex lens of larger focal length. Hence, smaller the focal length of a lens, more is its ability to bend light rays and greater is its power. Therefore, you can define that the power of a lens. So, you can define the power of a lens is defined as the reciprocal of its focal length. So, write that power of a lens. Power of a lens is defined as the reciprocal of its focal length. That is P equals 1 by F. P equals 1 by F, and SI unit of power. That is SI unit of power of lens is diopter. SI unit of power of lens is diopter. Next, let us take the third main. That is the sixth question. Draw a ray diagram of image formed when an object is placed at F1 of a convex lens. You know the method of drawing a ray diagram to show the formation of the image when the objects are at different places from the lens. Now, let us draw the ray diagram. So, first what you have to do? Children, what are the steps involved here? First, you draw a line of convenient length to represent the principal axis and mark 5 points. This is the middle point, and with same distance you have to mark here 4 other points. Here you take from this is the optic center, you take 2 centimeter. This is also 2 centimeter. So you take this is F1, this is F2. Again you take from F1 to 2F1. Again this is also 2F2. From here to here you must take again 2 centimeter. Here 0 to F1 2 centimeter. 0 to F2 is also 2 centimeter. F2 to 2F2 is also 2 centimeter. F1 to 2F1 is also 2 centimeter. So here mark 5 points which are at equidistant, and the middle point is for the optic center. Here we have taken 2 centimeter distance from each point. You can take 3 also, 4 also, like this way. Convenient equal length you can take here. But you must take the distances, all these 4 distances are equal. Then only you get the ray diagram, because you know that here F1 is the principal focus on one side of the lens, F2 is the principal focus of the other side, and 2F1 is the center of curvature of one side, 2F2 is the center of curvature of other side. Now here the object is at F1. Object is at F1. So take the object at F1. Here the object is at F1. You know the method of drawing the rays here. One ray is parallel to the principal axis. Draw a line to represent the ray parallel to the principal axis. So let us take the ray parallel to the principal axis. This is the ray parallel to the principal axis. You know that this ray enters into the lens, and refracts. After refraction, it passes through the After refraction, it passes through the principal focus on the other side of the lens. Next ray you take the ray which passes through the optic center. Here this ray passes through the principal focus. Next ray you take which passes through the optic center O. Here these two rays will meet at a point at a distance of infinity. There is chance of meeting of these two rays as they are not parallel, but they will meet at infinity. So you can say that the image forms at infinity. So what is the position of the image? The image is at infinity. So you take the position of the image. Position of the image at infinity. And size of the image, it is enlarged image, highly enlarged image. Size of the image, highly enlarged. And it is a real and inverted image. This image can be caught on the screen. So write that nature of the image. Nature of the image, that is real and inverted. You write real and inverted. In this way you draw the ray diagram and write the position, size and nature of the image. Position of the image is at infinity and size of the image is highly enlarged and nature of the image is real and inverted, as this image can be caught on the screen. Next question you take. The resistance of a wire of 0.01 cm radius is 10 ohm. If the resistivity of the material of the wire is 50 into 10 power minus 8 ohm meter, find the length of the wire. Here we have to find the length of the wire. What are given? Note down first here. Here the resistance of the wire is given and the radius of the wire is given, and also resistivity of the wire is given. What you have to find out? We have to find the length of the wire. Here you take, children, this question is already solved in the video lesson of the numerical solution of the chapter electricity, but here let us solve once again in the different way. So you take what are given here, that is R is given, radius of the wire that is 0.01 cm, and resistance is given, that is 10 ohm, and resistivity is given, so that is 50 into 10 power minus 8 ohm meter. As this is in meter, so you convert the centimeter also in meter, that becomes 0.01 by 100, that becomes, here as it is divided by 100, you take the decimal point again after 2 digits, so this becomes 0.0001 meter, that equals, you can write 1 into 10 power 1, 2, 3, 4. 4 digits are there. You can take 1 into 10 power minus 4 meter. You can take. Then write the formula to find the length. Here what you have to find out? We have to find the length of the wire. You know that here length of the wire, the relation among L and resistance and area of cross section and resistivity is L equals RA into RA divided by rho, that is the resistivity, and here R is the resistance and A is the area of cross section and this is the resistivity. Now you write L equals R that is given 10, and A, area of cross section means that is pi r square. You can write here, you write first R into pi r square by resistivity, and pi value you can take 3.14 into R value. R is 1 into 10 power minus 4 whole power 2, that divided by resistivity 50 into 10 power minus 8. Then you can write L equals, here it's 0 0 you can cancel, then 3.14 into, that is 1 into 10 power minus 4 into 1 into 10 power minus 4 divided by 5 into 10 power minus 8 it becomes. Then also you can write L equals, you can divide, you write here 3.14 into 10 power minus 4 into 10 power minus 4. You take this 10 power 8. If 10 power minus 8 is taken to the numerator, it becomes 10 power positive 8. That divided by 5 you write, that L equals. So it becomes 3.14 into 10 power minus 4 plus minus 4, that becomes minus 8 plus 8 divided by 5, that is L equals 3.14 into 10 power 0 divided by 5, that equals 3.14 divided by 5. So you will get 3.14 divided by 5 is 5 6 are 30.6. So you must write, because here 3 is not divisible by 5, you must take 31. So it is after the decimal point, so you write 0 point here. 1 is remaining, 1 4, 5 2s are 10, 4 is remaining, put 0, 5 8s are 40. So you got that equals 0.628. Here the formula is same. Solution you can do by using any convenient steps. So you got 0.628, length means here it is meter, 0.628. Next, question number 8. State Ohm's law. Give its mathematical expression. You know the statement of Ohm's law. The potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. This is called Ohm's law. So you can say V is directly proportional to I, and also V by I equals constant. That constant you can take R, which is also called as the resistance. So you can write V equals IR, V equals I into R. So R is a constant for the given metallic wire at a given temperature, that is called the resistance. So let us write the answer. Children, write the statement of Ohm's law. The potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. That is the statement of the Ohm's law. Mathematical expression of Ohm's law. Write the mathematical expression of Ohm's law. What is the mathematical expression of Ohm's law? V is proportional to I, and you can write V by I equals R. Here R is a constant. Then you can write V by I equals R means V equals R into I, you can take. Here V equals R into I. Here R is a constant, that is also termed as resistance. That is V by I is equals to resistance. That is the proportionally constant. Now the fourth main question. Answer the following questions. There are 3 questions, each carry 3 marks and total mass is 9. Now you take the 9th question, which carry 3 marks. What is an electromagnet? Draw a neat labeled circuit diagram to show how a soft iron piece can be transformed an electromagnet. Here, first let us write the answer to the question, what is an electromagnet? After that, let us draw the labeled circuit diagram to show how soft iron piece can be transformed an electromagnet. Then what is the answer for this question? A soft iron core placed inside a solenoid behaves like a powerful magnet when a current is passed through the solenoid. This device is called an electromagnet. When the current is switched off, the iron core loses its magnetism and so it is no longer an electromagnet. Thus, electromagnets are temporary magnets. Then what is solenoid? You know what is solenoid? It is a long cylindrical coil of insulated copper wire of large number of circular turns, and when a iron core is placed inside a solenoid and the soft iron core which is placed inside a solenoid behaves like a powerful magnet when current is passed through the solenoid. So read that a soft iron core placed inside a solenoid behaves like a powerful magnet when a current is passed through the solenoid. This device is called an electromagnet. That is the answer for the question, what is an electromagnet? The next part is, draw a neat labeled circuit diagram to show how a soft iron piece can be transformed an electromagnet. Children, it is a circuit diagram to show how a soft iron piece can be transformed an electromagnet. It is an example that when a soft iron piece can be converted as an electromagnet when electric current passes through the solenoid, and the soft iron piece which is kept inside a solenoid behaves like a magnet. That is called electromagnet. Now the 10th question. Write three differences between convex lens and concave lens. What is that question? Write three differences between convex lens and concave lens. Or question is there. It is a choice question. The questions are, three questions are there. What is meant by refraction of light? The second question, how does a ray bend when it passes from optically denser to rarer medium? Third sub question, what is meant by refractive index? Now let us write the three differences between convex lens and concave lens. So you know the difference here. Convex lens is the converging lens, concave lens is the diverging lens. Means convex lens converges the rays of light falling on it, concave lens diverges the rays. And next also you know that convex lens is thicker in the middle and thinner at the edges. Concave lens is thinner in the middle, thicker at the edges. And convex lens is having real principal focus and concave lens is not having real principal focus, that is having virtual principal focus, virtual focus. And in most of all the cases convex lens gives real images but concave lens gives always virtual images. These are the some main differences between convex lens and concave lenses. Now let us write the differences. Children, you write the differences. This is the column for convex lens and this is the column for concave lens. So write the first difference. Convex lens, it is thicker at the center than at the edges. Concave lens, it is thinner at the center than at the edges. Second, you write that it converges a parallel beam of light on refraction through it. And for the concave lens, you can write it diverges a parallel beam of light on refraction through it. And third one, it has a real focus. It has a virtual focus. So these are the three differences between convex lens and concave lens. Next you come to the OR question. What is meant by refraction of light? You know what is meant by refraction of light? The phenomenon of bending of light from its straight line path as it passes obliquely from one transparent medium to another is called refraction of light. So what is refraction of light? It is a phenomenon of bending of light from its straight line path as it passes obliquely from one transparent medium to another is called refraction of light. Children, let us write the answer. What is that? Phenomenon of bending of light from its straight line path as it passes obliquely from one transparent medium to another is called refraction of light. So you write that. Phenomenon of bending of light from its straight line path as it passes obliquely from one transparent medium to another is called refraction of light. Now the second question. How does a ray bend when it passes from optically denser to rarer medium? When a ray of light passes from an optically denser to a rarer medium, it bends away from the normal because angle of refraction is greater than the angle of incidence and it bends away from the normal. So let us write the answer. So you write, when a ray of light passes from an optically denser to a rarer medium, it bends away from the normal and angle of refraction is greater than the angle of incidence. So when a ray of light passes from an optically denser to rarer medium, it bends away from the normal. It bends away from the normal. So that you have to write the answer. Next question. What is that? What is meant by refractive index? What is meant by refractive index? So you write the answer that the refractive index of a transparent medium is the ratio of the speed of light in vacuum to the speed of light in that medium. So what is the refractive index? The refractive index of a transparent medium is the ratio of the speed of light in vacuum to the speed of light in that medium. So you write, the refractive index of medium is the ratio of speed of light in vacuum to speed of light in that medium. So you take that here, refractive index, that can be written in the form of what you can write here, that is refractive index equals speed of light in vacuum divided by speed of light in medium. That is the refractive index of a medium. So write the definition that the refractive index of a medium is the ratio of speed of light in vacuum to speed of light in that medium. So that you can write refractive index equals speed of light in vacuum, speed of light in that medium. Next, let us take the 11th question. In 11th question, there are two sub-questions. The first sub-question is, what are fossil fuels? And the second sub-question is, what are the two disadvantages of burning fossil fuels? Then what are fossil fuels? You know, coal, petroleum, natural gas, these are the fossil fuels. What they are? They are the fuels found in nature due to the decomposition of animals and plants which have remained embedded inside earth crust due to geological changes over millions of years. They are obtained from the buried plants and animals under earth over millions of years. This phenomena happened due to slow changes in earth processes. So here what you have to write the answer for this question. What are fossil fuels? Fuels which are found in nature due to the decomposition of animals and plants which have remained embedded inside earth crust due to geological changes over millions of years. That much is okay. Then what are the two disadvantages of burning fossil fuels? There are many disadvantages of burning fossil fuels. So let us take some. You know that burning of coal and petroleum leads to air pollution. They cause acid rain by forming oxides of carbon, nitrogen and sulfur. This affects our water and soil resources. And also burning of fossil fuels causes smog, which causes breathing problems and other hazards. So let us write in short about the fossil fuels and their disadvantages of burning fossil fuels. So you write that what are fossil fuels? Fuels found in nature due to the decomposition of animals and plants. Fuels found in nature due to the decomposition of animals and plants which have remained embedded inside earth due to geological changes over millions of years are called fossil fuels. So then you write the examples. Examples of fossil fuels are coal, natural gas, petrol, diesel, etc. you can write. So write here, etc. There are many fossil fuels. Next you write the disadvantages of burning of fossil fuels. First one you write burning of coal and petrol leads to air pollution. Second one you write they cause acid rain by forming oxides of carbon, nitrogen and sulfur. This affects our water and soils. Next third one, burning of fossil fuels causes smog which causes breathing problems and other hazards. So you write these three disadvantages of burning fossil fuels. Now you take the fifth main question. Answer the following questions. Two questions are there, each carry 4 marks, 2 turn marks 8. So that is the 12th question. In 12th questions, 2 sub questions are there, A and B. Again B is having 2 sub questions, first and second, and it is a choice question, and the choice question is a big question which carries full 4 marks. Now let us take the first option, that is 12th question A. Describe an activity with a diagram to demonstrate that a current is induced in a coil whenever the current in the neighboring coil changes. And its B question, if the speed of rotation of the armature of a generator is doubled, how will it affect the maximum induced current and the frequency of induced current? And the choice question is, explain the construction and function of the electric generator. Now you take the first 12th question A. Describe an activity with a diagram to demonstrate that a current is induced in a coil whenever the current in the neighboring coil changes. Children, it is a diagram of the activity. Here which are the apparatus required? 2 different coils of copper having about 50 turns and 100 turns. So it is a coil of 50 turns, it is a coil of 100 turns. A non-conducting cylindrical roll, a galvanometer, battery, plug key and a connecting wire. Here you take the connecting wire, battery, plug key and a galvanometer, and it is a non-conducting cylindrical roll. Non-conducting cylindrical roll. So what is the activity here? Take these 2 coils, insert them over a non-conducting cylindrical roll as shown in the figure. Connect the coil 1 having larger number of turns in series with a battery and a plug key. Here you take the coil with more number of turns and connect this to the battery and plug key. Connect the second coil which is having less number of turns to the galvanometer through the conducting wire. and plug the key, insert the key and observe the galvanometer which is connected to the second coil, and you can observe the deflection in the needle of the galvanometer. You will observe that the needle of the galvanometer instantly jumps to one side and just as quickly returns to 0. It jumps to one side and comes back to 0. It indicates a momentary current in coil 2. So when the plug key is inserted here, you know that there is a flow of current through this coil. As there is a flow of current through this coil, there is a momentary current in coil 2. Disconnect coil 1 from the battery. Here, switch off the key. You will observe that the needle momentarily moves but to the opposite side. Here, needle moves to the opposite side. It means that now the current flows in the opposite direction in coil 2. So in this activity you observe that as soon as the current in coil 1 reaches either a steady value or 0, the galvanometer in coil 2 shows no deflection. We can conclude that a potential difference is produced in the coil 2 whenever the electric current through the coil 1 is changing. Coil 1 is called the primary coil and coil 2 is called the secondary coil. As the current in the first coil changes, the magnetic field associated with it also changes. Thus, the magnetic field lines around the secondary coil also change. Hence, the change in magnetic field lines associated with the secondary coil is the cause of induced electric current in it. This process by which a changing magnetic field in a conductor induces a current in another conductor is called electromagnetic induction. Children, now let us write the activity. Children, draw this figure and write the explanation of the activity as follows. So what you have to write, take two different coils of copper wire having large number of turns, say 50 and 100 turns respectively. Insert them over a non-conducting cylindrical roll as shown in the figure. It is shown in the figure. Connect the coil 1 having large number of turns in series with a battery and a plug key. Also connect the coil 2 with a galvanometer as shown in the figure. Plug in key. Observe the galvanometer. You will observe that the needle of the galvanometer instantly jumps to one side and just as quickly returns to 0, indicating a momentary current in coil 2. Disconnect coil 1 from the battery. You will observe that the needle momentarily moves but to the opposite side. It means that now the current flows in the opposite direction in coil 2. In this activity, we observe that as soon as the current in the coil 1 either a steady value or 0, the galvanometer in coil 2 shows no deflection. We can conclude that a potential difference is induced in the coil 2 whenever the electric current through the coil 1 is changing. That is the explanation of the activity. Now the question B, if the speed of rotation of the armature of a generator is doubled, how will it affect? The first one, the maximum induced current. Second, the frequency of induced current. You know that both of them will double. If the speed of rotation of the armature of a generator is doubled, the maximum induced current gets doubled and also the frequency of induced current gets doubled. So let us write the answer that here you take, if the speed of rotation of the armature of generator is doubled, the maximum induced current gets doubled, the frequency of induced current also gets doubled. That is the answer for the B question. The choice question or question, explain the construction and function of the electric generator. We have discussed many times about the construction and function of the electric generator. Now let us see the answer. See, this is the figure of the electric generator and its function. Now let us write about the construction. An electric generator as shown in the figure consists of a rotating rectangular coil ABCD. Rotating rectangular coil ABCD placed between the two poles of permanent magnet. Placed between two poles of permanent magnet. The two ends of the coil are connected to the two rings R1 and R2. Here you observe the end A is connected with the ring R1 and the end B and D is connected with the ring R2. And you know that the two conducting stationary brushes B1 and B2 are kept separately on the rings R1 and R2. Here R1 ring is connected with B1 and R2 ring is connected with B2. And the two rings R1 and R are internally attached to an axle. Outer ends of two brushes are connected to the galvanometer to show the flow of current in the given external circuit. Here you know that the two ends are connected to the galvanometer. You know that galvanometer is a device to detect the flow of electric current. Even it detects a small amount of current. That is about the construction. Now you take the function. When the axle attached to the two rings is rotated such that arm AB moves up and the arm CD moves down in the magnetic field produced by the permanent magnet, and the coil ABCD is rotated clockwise in the arrangement. Here when the axle is made to rotate, here AB moves up, this arm moves up and this arm moves down. And by applying the Fleming's right hand rule, the induced currents are set up in these arms along the direction A to B and C to D, A, B and C, D. Thus an induced current flows in the direction A, B, C, D. Here what you have observed, by applying the Fleming's right hand rule, the induced currents are set up in these arms along the direction A, B, C, D. Thus the induced current flows in the direction A, B, C, D. This means that the current in the external circuit flows from B to B1. Here you can observe that current flows from A to B. Here you observe A to B and C to D. So here what happens? The current moves from the brush B2 to B1 in the external circuit. Here in the external circuit the current moves from B2 to B1. Then after half rotation, arm CD starts moving up and AB moving down. As a result, the direction of the induced current in both the arms changes, giving rise to the net induced current in the direction DCBA. Here in the next half rotation what happens? CD comes up and AB comes down, and the current flows from D to C and here from B to A, and in the external circuit the current flows from B1 to B2. As the induced current flows in the direction ABCD in the arm, the current in the external circuit flows from B to B1. Then after half a rotation, arm CD starts moving up and AB coming down. As a result, the direction of the induced current in both arms change, giving rise to the net induced current in the direction DCV. The current in the external circuit flows from B1 to B2. That is discussed. Thus, after every half rotation, the polarity of the current in the respective arms changes. Such a current which changes direction after equal intervals of time is called an alternating current. Shortly it is abbreviated as AC. This device is called AC generator. To get direct current, what you have to do? We have to use the splitting type commutator. That is to have the current in the same direction. That is, the DC means direct current which does not change its direction with time. Here the commutator, splitting type commutator, instead of the rings R1 and R2, they are used. Now you take the 13th question. What is that 13th question? The values of current I flowing in a given resistor for the corresponding values of potential difference V across the resistor are given below. That is I 0.5, 1.0, 2.0, 3.0, 4.0. Next 1.6, 3.4, 6.7, 10.2, 13.2. They are the corresponding volts with respect to the current. Here what you have to do, you have to plot a graph between V and I and calculate the resistance of that resistor. Here we have to draw the graph between V and I. Now let us take the potential difference V on the x-axis and the current I on the y-axis. Now you mark the origin and now let us take the potential difference. It starts from 1.6. So let us take 1 unit equals 1 volt. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and here let us take on the y-axis. Here up to 4 is there, so you take 1, 2, 3, 4. Now the first here V is 1.6 and I is 0.5. So 1.6 means here it is, the middle of 1 and 2 is 1.5, little greater, and 0.5 means it is between 0 and 1. So the approximately the point comes here. This is what? 1.6, 0.5. Next 3.4, 1.0. 3.4 means I am in the middle of 3 and 4, that is 3.5, so little less. So you take here, and 3.4, 1. 3.4, 1. Next 6.72. 6.7, it is 6.5, middle of the 6 and 7, and maybe here, and 2. 2 means can take here, and then next one is 10.2, 3. 10.2, it is in between 10 and 11, that is 10.5. Approximately you can take here, and that is 3. 3 may come here, that is 10.2, 3. Next one is 13.2, 4. 13.2, 4. 13.2 will come here, approximately it is 13.2, 4. Now let us join all these points. If you join this, all these points, you got a straight line of the graph V against I. Now here what you have to find out? You have to find the resistance of that resistor. So here you take any 2 points. Take any 2 points here, that is left to you. You take the point 2 and 3. So take 2 and 3. And the 2 points, you got that is R is equals to V2 minus V1 by I2 minus I1. V2 minus V1 by I2 minus I1. So you take the point here, 10.2 minus 6.7, that divided by 3 minus 2, that is 10.2 minus 6.7 by 3 minus 2, that you will get here 10.2 minus 6.7. 10.2 minus 6.7 you will get, that is 12 minus 7 is 5, and here what is remaining? 9. 9 minus 6, 3. 3.5 by 1 you will get, that equals 3.5 ohm. You got the graph and also you got the resistance of that resistor. Now the question B, why are copper and aluminum wires are usually employed for electricity transmission? Copper and aluminum are the good conductor of electricity. Their resistivity is low. Copper and aluminum have low resistivities. When electricity is transmitted through copper and aluminum wires, the power losses in the form of heat are very small. Therefore, copper and aluminum wires are usually employed for electricity transmission. Now let us write the answer. Write that copper and aluminum have low resistivities. When electricity is transmitted through copper and aluminum, the power loss in the form of heat are very small. Write the answer that copper and aluminum have low resistivities. When electricity is transmitted through copper and aluminum, the power loss in the form of heat are very small.